Hey everyone, welcome to the Mix Code channel. And we still continue with that crash course. And today we're going to be talking about classes, right? So basically, what are classes? We're going to look at some few examples of how to use them. So classes are blueprints of information, right? So and the blueprint of the logic we created in one place, right? That is the class, and then we reuse it in many other places, right? Because we have this main logic. Our main logic is whatever that we're going to be using, but it's going to be seated in something called a class, right? And now this reuse that we are talking about is actually going to be called instances of the class, right? So it's just going to be called instances. So the usual dance, we're going to go ahead and create our folder. Okay, so we'll come down here to bin and we'll call it class. Let's just go with classes. Okay, and we'll start with the first example, example one dot. Okay, and we can do this. Open that in the terminal. Okay, so there's that. And so where does that, so we are not going to start with our first example here, but we're just going to create a very simple person class. Okay, so we'll start here with the main. Okay, so now to create a class, we use the keyword class, okay, followed by the name of the class, and here we're actually going to be using person, right? So here we just have a simple person class, so we could say here cons person1 is equals to person. Okay, now the constructor being called isn't the constant constructor, try removing const. Okay, well, you see here that before we even jump into constructor and all of that, is that classes can possess a constructor or not, but I'll always advise you to provide to it a constructor, right? And this constructor, when we have a constructor, we have fields. These are like contracts, right, that we're writing between the class. Okay, and we also usually have um so yeah, so these are like contracts that we write, right, between the class and the constructor, as well as the items which are in it. So and this person is what is holding a copy of this person's class, right? So it's actually an instance of this person's class. So we could go then ahead and create some couple of stuffs like um final. Okay, we could say a person has a name and the person has an age. Okay, age, and we can then go then ahead and create a person constructor. So to create a constructor, we go with the persons with the class name, right? And curly braces, because constructors are just kind of like special functions, right? And the constructor's function is to create an instance of that class. So that's it. And you saw that earlier we were able to create a person class without a constructor, because by if we don't provide it a constructor, then that behind the scenes is going to assign it a constructor. Okay, so that's like some sort of invisible constructor being available or provided to us. So we put this curly braces and we're going to say require this dot each. Okay, it's pretty much the same thing as functions, right? um, I think this is a name, this, so we do the same, require this dot age. Okay, and we do this. Okay, this has to be name. Okay, and so now you see here that we can call this person, since we have made this person's class um, a required constructor, or this kind of constructor, so we obviously have to provide the parameters, right, which are the name and age, which are obviously required. So we can say here that name. Okay, we can go with John. Okay, John, and age, let's say something like 20. So now we are happy with this, because the compiler or the static analyzer, the that is not happy with this because we have not provided the required parameters which are to it, right? So this is one way of creating a constructor. So another way that we could go ahead to create a constructor is by doing this by using I think it's called literal initializer list. Okay, an initializer list where we could say person. We could still go ahead and say const person. Okay, and we still provide the required okay string name, and required, this is going to be int h. Okay, and now the way we create this list initializers is that we do this using the semicolon. Would say name is equals to name and age is equals to age. Okay, so we get this now. So per now that says, hey, wait a minute, like you don't need to do this, like there is a better way of doing this. And if I do this, if I try to follow what the VS Code has provided me to me as a quick fix, right, we get this down, the this dot name, and we do same for the age. Okay, and we also get this, and now we can add the required keyword. So that was just one way of creating parameters. I'm just going to comment this. So that was another way of creating a constructor. Okay, comment that out, and so we cannot come here and say print. Okay, we can print persons one dot name. Okay, and we do the same with the age. And if we try to run that here and say that example one, okay, then we get John and 20. So that's that for example one, and then we're going to move down to example two, where we're going to create. So let's first of all create our example two. Let's provide that example two dot dot. Okay, so now in this example two dot dot, what we're going to do is that we're going to create a person's instance with full and age, right, the constructor, and we're going to provide in such a way that whenever we create the constructor, it will have some default values, right, and we're going to provide that in the initializer list. So let's go ahead with the main function and say again class person. Okay, and we then provide still all of these fields here. Okay, that's that. So now we're now gonna ahead and still copy this. Okay, copy this. So now what this example is all about is that in a class we don't always like have just one constructor, right? We can have a constructor, but it's also possible to have more. So we could create a constructor in which it initializes the name and age fields by default with already hard coded values, right? So how then do we do that? I'm sure you're asking yourself. So we say const, right, and we say person, the name of the class, and then we now provided the name of the constructor, say for example default, or let's go with a small d, say default, and we do this. Okay, and we still use the list, yeah, the list initializer, I think it's initializer list, something like that. So we can say here name is equals to John. Okay, and then we provide the age, which will be equals to, let's say 24. Okay, default is actually a keyword, so we'll just say delf, say just call it delf, or let's just call it constructor John. Yeah, I think doing it that way will kind of like be better, so let's say John. Okay, so this makes it in such a way that whenever we call this, so we are then going to say const, okay, person one is equals to this person here, this person John. Okay, now we can go ahead and print person one dot name. Okay, and we can still go ahead and print person one dot age. Okay, So now with this, now we see that if we try to run that in a terminal by using example 2, we still get John and 24, which is actually the values that we had there. So this is another way of providing a constructor. Okay, so we also have some pretty other ones. So we could let me take this down. Okay, we could also provide a constructor which just prints, which accepts the age as a parameter, but the name is hard coded, right? So we could say still person, okay, and say Austin, okay, something like that. And here we're just going to say we're going to have the name Austin, okay, at the end. And now this age, we're just going to accept it as a parameter, right, by saying this dot age, and that's it. So now if we try to call the persons with this constructor, then we will have to pass in the age, which is going to be initialized in this age field. Okay, so let's go ahead and try that. Okay, so we would then have const person 2. We're going to provide a person 2. Okay, so we're going to say person Austin, and we see here that we get an age, so we could get something like 21. Okay, and then try to print that out. Okay, so we would then get this, and we can just recopy all of this, paste this here, and change this, and when we clear that and we try to run that again, then we get Austin and 21. So that's another way of creating a constructor. And as well, we could also have um, optional provided values, right? So a constructor with optional provided values. I think I should just call it that way. So we're going to have another one, say const person order, okay, and in this order we're just going to get this. So we're going to say the string is an optional name, okay, name, and the int is age, okay. So we're just going to have the name here. So in the at least initializer, we're going to say if we have a name, if we don't have a name, or if the name is actually null, then use order, okay. But otherwise, well, if we have as well as the age, okay, if the age is null, then we're just going to take something like 24, okay. So if we now come here and copy this part again and come down here and say 3 3, or here we're just going to say 4.h, and we can come here and say person 3 is equals to person dot order, okay, and we call the constructor. Oh, and here we don't have any issue, so we could say person name, as well as we can go here and say person 4, okay, and we just pass in only the name, okay, and say something like Dewey, okay. And here we could just come and just get the name, and let's try to divide that, okay. So with this now, we try to do something like this, example 2, okay. We get order and Dewey, okay. Example 3 dot name, what's example 3 dot name order? Did I not change the example 3 dot name? Oh yeah, order. So it's okay, it works. So that's that. You can go ahead and try with the other example. So we are done with that. So let's move on now to example 3. We're going to be talking about example 3. So example 3 dot dart, okay. Now in example 3 dot dart, we will talk about subclassing, right? Which is another concept, which is a concept known as inheritance, right? That's inheriting from one class to another, right? So we'll basically just have a class vehicle. So we're going to say class vehicle, okay, and it's going to have final ints, let's say wheel number, or number of wheels. Let's just call it like tires count, okay, or maybe wheels, anyone. So we could get this tires count, okay, and we then have the const. We have the constructor here, and this constructor, then we just say this dot tires count, and that's that. Okay, so we could then go now to the terminal. Okay, to the terminal, let's provide a main function, and so we want to print vehicle. Okay, let's say with this, and we set that example 3. Okay, let me try to bring this down a little bit, okay, so that we can actually see what's happening here. So if we do this, then we get instance of vehicle. Now the reason why we get instance of vehicle is because by default, all classes extend objects. Like they do this, they extend the object class. So even if you don't provide this, but behind the scenes that does this for you. So this stuff here is coming from the object class, which already has a method called the toString. So whenever you do something like this, it you're actually calling the toString method. Or let's try to do something like this. You're actually calling the toString method on the class itself, which is actually coming from which is available on objects. That's why we're able to do this, and you see we still get the same thing: instance of vehicle, instance of vehicle. So now what we can do here is that we need to provide then a toString method for this case, because um, if not, we won't be able to see anything at the terminal, and we'll keep having the instance of vehicle. So we can now create now the toString method by this. So by saying toString, so it's something like this, okay, toString, and it's a function, or let's say method, but we're going to get to that, and we're going to say runtime type has tires count, or let's say tires, or let's say wheels. Okay, so now it gives us a little information or warning that the member toString overrides an inherited member. So now the inherited member, remember, is because of this, it extends the object class, right? So in what it's just trying to say here is that we need to provide we need to annotate it with the override, right? Saying simply mean that we are going to use this toString, but we're going to provide our own implementation. So if we do this, we're actually overwriting, not overriding. So so we just do that by providing it with the at sign with override, and then you see our compiler or that application is now happy. So if we now try to do this example 3, then we get that. Okay, so but we only don't end here, we could go further as well by trying to say by creating a class car, which extends, okay, which extends vehicle, okay, which extends vehicle, and we could say const car, and do this, and you will say okay, fine, so that's all. But now we see that we have an issue here, because our constructor or this class is actually yielding at us, or yelling, okay, and implicitly invoked an unnamed constructor from vehicle that has required parameters. So the reason why we say it extends, or it takes some of these attributes from the parent, right? You can necessarily select what is being extended or what is being taken from the parent class, but it basically kind of like takes everything. So what it's trying to say here is that we have provided a constructor, but this class constructor here is accepting something since we're extending from it, right? So there are a couple of ways we could do this. So we could do this by saying this, okay, by saying super for, okay, this is another way of doing it, right? And this, and also let me just show you to the other way. So the other way could still be car, okay, and we call the super.constructor tires count, such that what this means is that okay, let's just treat each example so that we kind of like see what is happening. So we are going to have something here and say final car, okay, is equals to car, okay. So now for the first case, for this second case, what it's just trying to say is that whenever we create or whenever we have an instance of this car class, right, we are forced to pass the tires count, which can make your code kind of like redundant for maybe cars, which we all know that have four vehicles by default and four tires, and which would change, right? So it make your code cumbersome if we're to go ahead and say car 2, okay. Then we still have again to come again and create again this, which is actually kind of like cumbersome. So but there are certain cases where this is kind of like useful, right? So that's not to say it's not useful or it's useless, but there are cases where that can become handy. So we also have this, which is this other case where the super already passes 4 to this vehicle class, right? So and with that we could just go ahead and say final car 3, okay, is equals to car, okay, and we get this. So basically that's it. And now with this super, what super does is that it's kind of like a keyword used to um send, let me just use the word, let me just put in this way, like get data from the base, right, or the child, and pass it to the parent, right, should in case the parent has parameters that are required. So what we could do here is that we could get a print, okay, and we could say car 3 dot, or we could just even go ahead and just print it, okay. So we can clear our terminal and say that example 3, and we see car has 4 wheels. Why? Because by default this car has 4 wheels. So if we try changing it here, okay, we also get the same change here, 4. So this now becomes handy because handy with the fact that we can create multiple instances of it without necessarily having to pass the entire accounts or yeah to it. So that's that for that. So we move now to example 4, where we are going to be talking about something different. So we're going to say example 4 dot dot, okay. Now in this example 4 dot dot, we're going to be talking about getters, okay, getters in classes. So we still have a main function, okay, and we have this person's class, okay, and this person's class obviously has a final, let's say final string, okay. We have a first name, final, and we have a last name, okay. Now there are basically two ways, and let's provide a constructor for this. Let's provide a constructor. So now there are basically two ways we could say, for example, we wanted to get the full name, right? There are two ways we can do this, and then we are going to see which one is like preferable over the other, right? In certain cases, because there is no bad one compared to the other one, just that both of them have their case scenarios where one is more efficient or effective over the other. So I'm going to start with the first method, right? I'm just going to copy this person's class multiple twice, right, so that we get to see. So the first method, say we wanted to get the full names of this person's class that will be created, right? So the first method is that we could come here and create and also add another string and say full names, right? And then we will then have to either pass it here to the required and say this dot full names. But this kind of like it's weird because you have already asked for my first name, you have asked for my last name, and you still require me again to do the full names, right? So this is weird and we won't want to do this. So I'll just explain on that. So what we could do then is that we could go through the list initializer. I think I'm kind of like confused. I don't know if it's list initializer or it's initializer list. Just let me know down in the comment what is it actually. So we then do this, okay. Now we could go through the list initializer by saying that we're not going to have these full names. Okay, these full names in which we're going to provide um the first, which is the first, and then the last name to it, like this. Okay, so if we then try now to create a person, so let's go ahead and try to create a person one. Okay, and say person here. I think let's just call this, okay, so let's say Austin Garrett. So we shall now have something like this. Okay, and it says expected to find is the constructor being called is in the constant constructor. Okay, so now with this, now we can be able to print person one dot first name. Okay, and be able to print the last name and the full names, right? So now we have this. So, and if we try to run this, and say this, and then we get that Austin Garrett and Austin Garrett. Right now, let's take now the second method, okay, which is actually what we are talking about, which is getters, right? Working with getters. So we are just going to say here this is a person class 2, okay, and this is going to be 2, and we're going to get rid of this. Okay, now the way we create getters is by saying, or it's by doing something like this. Let me remove this out. Okay, so now the way we create now getters is by saying we could have a string. Okay, I think it's usually get. No, it's actually string get, and we could say full names. Okay, and then we just return what it is. So it's the first name and the last name combined. Okay, so now this is what we have here as this getter, as this getter. Okay, so with this now we can come here and let me just put line breaker, something like this. Okay, and we could still come here and say const person2 is equals to person2. Okay, now we're going to say John Doe. Okay, and I'll just copy all of this now and just replace it down here. Okay, so now we're going to still get the first name, but this is going to be person2, and then the last but not final, we don't get our full names. Okay, still the same thing, and we see that if we try running that, everything it's still okay. We get no errors. John Doe, and then John Doe. Okay, so now what the difference now between the two is that with the getter is called only when we try to get access to this. So this thing is actually computed or calculated only when we get access to this. But this constructor, but this other method, or by using the list initializer, we're actually saying that whenever the constructor is called, okay, or whenever the constructor or whenever this class is instantiated, right, this constructor is going to build this immediately, right? So it's basically this, that's what it means. So the difference is that, or what you can do is that once when you have heavy computation or calculation that has to be done, um then you can kind of like do that at the same time as the constructor is being called, right? But if you just have some little computation or nothing, then you can do that only when on a getter. Okay, so that's that for working with getters. And yeah, So we're going to move now to example 5. Okay, so we're going to move now to example, so not there. So we're going to move to example 5, 5 dot dot. Okay, so in this example 5 dot dot, we're also going to be talking about methods, right? Methods which are actually some sort of functions that belong only to classes, right? So we're going to have again a main here. Okay, and we're going to have a class here called car. And we're going to say int speed is equals to 0. Okay, void drive, and in this void drive we're going to get required int speed. Right now in this int speed we're going to say this of speed is equals to speed, and then we try printing, and then we're now going to print, say accelerating to speed kilometers per hour. So that's that. So now you can also, so we can provide also the drive, the stop. Okay, so let's provide the stopping function. So we can say here stop, and we can remove this. Okay, and not necessarily need this, and then we can say here 0, and we can copy this and say stopping. So we can say stopping and then stopped. Okay, so that's it. So this is how we then create methods inside classes, right? And the way then now we can now make use of it is by instantiating the class car by saying final. Okay, and we can say car is equals to car. Okay, and then we can now go ahead and print car dot drive. Okay, and I say that for the drive we have to provide a speed source, so let's say 10. Okay, this expression is a type of void, so its value can be used. Okay, so we then call that like that. Okay, and then we try to print car dot speed. Okay, and the same thing with the stop, so we can say car dot stop, and then that's all. Then we can print the car dot speed at a time. Okay, so now with that we can say example 5, and then we get that, so accelerating at 10 kilometers per hour, 10 stopping stopped, and then we get the new speed now, which has been changed. So basically this is just how you write functions or methods in a class, and then we have seen how we can access them with values and change values to it, right? So yeah, so that's that. And also the reason why we kind of like set speed here and speed here, okay, it's just so that we should be able to accept a speed which is different from this, because if we don't do this here and we do something like this, you say it's all pointing to the same variable, so we need to be able to get the speed and then store it in here. And what's the best way of doing that if it's not by using the this keyword on the class itself to be able to access this property, right? Okay, yeah, that's that for example 5. So in example 6, dot dart. So in this example 6 dot dart, we're going to be talking about setters, right? So we earlier looked on getters. Now we're going to be talking about setters. So one short thing I'm going to kind of like do, it's going to go on and copy that code that we had in example 5. Okay, so I'm going to say example 5. Okay, so we're going to get this here, so example 5. Okay, and we can close this. We can provide a main function. I think the main function will just come at the end. Okay, and so now what we're going to do here is that we are going to provide a setter indicator. So we're going to make this field private. Okay, and we're going to say int get speed. Okay, it's going to be the speed that we provided up there. Okay, so well, we're getting a bunch of errors though. Redirection. Okay, this. So and now we would now have to provide a setter. Say because we provided a case where let me just go back to example 5. We provided a case where we were doing something like this then, but we can also have something like this, and the program will still compile. Why we don't want this, right? We don't want a car running with -1. Well, we could still look at it from a physics point of view that maybe it's the car something, but that here is not going to be allowed. So we don't want to be able to allow such negative values, right? Let's just say we don't want to be able to take in negative values. So we're going to say set speed. Okay, and we're going to take the speed. So we're going to say new speed. Now in this new speed, we're going to check. Okay, we're going to check if the new speed is less than 0, right? And if it's less than 0, then we are going to throw an exception. So we're going to throw an exception saying speed or must be greater. Yeah, let's just say must be greater than 0, or speed cannot be negative. It's one and the same thing. Okay, so else what we're just going to do is that we're going to take this underscore speed. So we're going to take the new speed and assign it to the underscore. Okay, so basically this is it. Nothing has still changed. Okay, we still use this speed to be able to do this. Okay, to be able to do the setting on top of this speed here. So now you see now the instances to which it's pointing to, or to the different places to which it's pointing to, which is this, right? So if we went now to our main class, okay, if we went here and we said main car, or let's just say call it, let's just say final car is equals to car. Okay, and if we try, but do we even do this? No. Oh yeah, so in there we can say car.drive. Okay, and if we say -1, okay, but since we're going to kind of like have an error, I don't want the application to crash, so we're just going to use a try catch block. So in this try catch, we're going to have this, and basically that's all. So if we clear our terminal and we're trying to run 6, right now we get this exception that speed must be greater than 0, which actually means that our code works, right? Because we provided it a negative value, and it came here and it saw that the -1 was less than 0, which is actually true. So we entered now this block scope, and what was here was executed before the program had to terminate, right? So that's a use case of setters. We've seen how we can work with setters and getters, because they're actually kind of like really essential, especially when you want to enforce a particular type of behavior. Okay, so the next example we're going to be looking at is example 6. Okay, so in example 6 we're going to talk about let me see, are we going to talk about static properties? Okay, in example 6 we're going to talk about factory constructors, or even before going to factory constructors, we're going to talk about static properties and static fields, which is actually going to be example 7. Okay, so we're going to say example 7, 7 dot dart. Okay, now in this example 7 dot dart, we've seen static fields and we've seen fields and we've seen methods, but we haven't talked about static fields, which on the class which is available on the class itself, not on instances, right? Because methods, normal methods, are available only on instances of the class, but static methods are available on the class itself. Okay, so that's a little side note to take note. So we could go around and try to create a little game. So we could do this. Okay, and we could create a class car, which is actually just going to give us the number of times the class car has been instantiated. So we can say static int, okay, underscore car instantiated. Okay, and we start at the value of 0. Now we get a static int get, okay, a getter, car instantiated, nope, instantiated is equals to this, okay, is equals to the car instantiated, okay. And I don't know why I keep forgetting this. So now we now provide now our function, right? So with the function now we are going to call it static void increment car instance, or let's just give it like that. So we're just going to call it increment car instance, and all we're just going to do is take this private value and just increment it. That's all. So and then we, for this car, we can now provide it with a constructor. Let's say something like final. Let's just provide it with a name. Okay, with a name, and yeah, let's just leave it with a name, not so something too fancy. So we can say car required this dot name. So we're going to say this dot name. Okay, so this is just a simple logic, and then we're going to provide a body down for it. Okay, and in this body we're going to call the increment instance class. Okay, so basically what it's going to do is that whenever we create an instance of this class, okay, this method is going to be called, right? So let's say we have a couple of cars here. Car 1 is equals to car, and we're going to say something like John. Okay, let's just create even something like 2, 3, 4, and let's just give them some kind of names. Geo box. Okay, so not really that important, but now we should be able to trace what's actually happening. So if we print car 1 dot the getter, did I provide a getter? Okay, it's available on the class, that's what I said. So we have this car instantiated. Okay, and we do the same if we try doing this and this and also this. So if we try clearing our terminal, we'll say that example 7. Okay, so now we see now that it counted from 1 to 4. That means that we have 4 instances of the car class in our code. So let me just kind of like turn this off for now, not really useful. Okay, so that means we have 4 instances of car in our code, and if we count correctly, this is 1, 2, 3, and 4. Okay, so it's able to successfully count, but this is just to demonstrate the ability of static methods and static fields or properties, as we'll call them. So the last example, which is actually example 8, In the last example, which is actually example 8, we're going to be talking about factory factory constructor. So some people usually don't or are not able to differentiate between a class and a factory constructor, like yeah, the special function constructor and the factory constructor itself. With that, the factory constructor creates instances of the subclasses. Okay, while the normal constructor creates an instance of that class itself. Okay, so let's move that out and say main. Okay, from this main we can then have a class vehicle. Okay, and this class vehicle, we have nothing fancy, just the vehicle. Okay, constructor, sorry. So basically that's what we have, and then we just have a couple of this and this, and then we could say, for example, car extends vehicle extends. Okay, so now for the next one we're going to have bike or bicycle. Okay, so here this is supposed to change, and also this, so it's supposed to change. Okay, so now we have this extending that. Okay, and let's provide it to string. Let's also provide it to string. Let's override the to string method. Okay, so now in this to string method, what you're going to say vehicle is of type underscore runtime, and then let's not forget that we need to annotate this. Okay, so basically this is it. And what we could do here is that if we wanted to create a vehicle, say for example we had a final, and let's just call it v. Okay, we're going to have the vehicle, not from example 3. Okay, and we still can print the v, and we can come here then to a terminal and clear that and say that example 8. Okay, now an instance is a type of a vehicle is a type of vehicle, right? Normally. So, and as well as if we needed a car, then we could do same and say something like C. Okay, and we have car, and then we could now copy this and say C. And say C. So we try to run that, and then we have vehicle is of type vehicle, vehicle is of type car. Okay, so basically that's working, but we haven't yet made use of the factory that we talked about. So now this is how we make use of the factory. We say factory. Okay, then after saying factory, the name of the class. So we're going to say the name of the class. So we're going to, for example, say vehicle. Okay, dot car, and then with this we're going to provide it with the car class. Okay, likewise it's going to be done, for example, let's say for the bike, I'm just going to call it the bike. So with this then, and this, because the method has not been the class has not been created, so we then do this, and now everybody's happy. So that with this we are able to just do vehicle dot bike, and then it's going to create for us an instance of the bike, and so on and so forth, as well as for the car. So if we try doing this, okay, example 8, and we see vehicles of type bike. So that's basically what the factory constructor help us to do. Nothing strange, nothing fancy. And yeah, we've come to the end of this lessons, and I hope you can actually kind of like enjoy the lectures on the on the classes. Okay, so don't forget to like, share, and subscribe, and also um yeah, enjoy and see you in the next chapter.